All right, today we're going to discuss a different type of loop. A brief recap of what our while loops were. We talked about this last class. We have our condition. When that condition is true, we're going to run that while loop's body code and loop and loop and loop until our condition is false, and then we will run any code after the loop. So today we're going to discuss another type of loop that we can use in our programs called the for loop. For loops are designed to allow us to repeat a block of code a specific number of times. And this is one of the places in which Java is different from especially Python. They have very different formats for their for loops. So the syntax for a for loop in Java is for, and we're going to initialize an iterator. We're going to have a semicolon. We're going to have a condition, another semicolon, and then we're going to change our iterator. And then we're going to have our body inside of curly braces, just like we are now used to. So here's what the flowchart for a for loop looks like. First, we're going to initialize our iterator. And the iterator is the variable we're going to use to keep track of how many times we've gone through the loop so far. We have a condition in our for loop. Just like with the while loop, as long as that condition is true, we're going to run our body code. And after the body has run, we're going to run that little block of code, changing the iterator. And we're going to check the condition again until the condition is false, at which point we will jump until after the loop. Updating the iterator here is built into the loop. It's part of the loop process. So instead of including it in my body, like I might have to for a while loop, this is built into my for loop. It's part of how it runs. So let's look at some code. Here's that demonstration I had, the pseudocode. So for a very common name for it, the iterator, that variable is going to be I. Usually you're going to want it to be an integer because it's just going to keep count of how many times you've looped. So this variable, the iterator, is going to be controlling the execution of our for loop. It's going to change each time through the loop. And since it's a variable, its value can be used inside of the loop. Sometimes it is referred to as the loop control variable. This variable will only exist inside the for loop. And afterwards, if you try to access that variable I, it will not exist. So after your for loop is finished, I ceases to exist. So we are declaring and initializing our variable here. Next, we are going to have our condition. So my example is saying I less than 3. So as long as my iterator is less than 3, I'm going to continue looping. So the condition for our for loop will almost always be dependent on our iterator reaching some value. This is going to give us control of how many times we're going to run our loop. And then to change our iterator, an example of this might be I++. We're going to add 1 to I each time the loop runs so that we can actually reach that Boolean condition being false. Does this very basic introduction make sense so far? Cool. All right, let's look at an example. Let's run through one. So once we hit a for loop, first we're going to run that initialization. We're going to create our variable I. We're going to initialize it to the value 0. We're going to check our condition. I is currently less than 3. Yep. So we're going to run our body. We are printing I, printing 0. After our body is over, we're going to run the iterator change. We're going to increase by 1. And then we're going to just check our condition again. Once this has happened once, it is not going to happen again. We're only going to run this at the very beginning of our for loop, right when we hit it, right when we creating and initializing that variable. After that, we're going to only use the iterator change thing to actually update it. So our current value of I, 1, still less than 3. So that's still true. So we're going to print I. We are printing 1. We're going to increase I again. Their body is finished. We're going to jump and check our condition. 2 is still less than 3. So that's still true. We're going to run our body. We're going to run our increment. We're going to increase our iterator. Now, is 3 less than 3? No, it is not. 3 is not less than 3, so our condition is false. Our loop is now over. So we are allowed to start that iterator variable wherever we want. It does not have to start at 0. So if I start my iterator at 1 with that same condition, I'm going to get the outputs 1, 2, because I didn't start at 0. I can even initialize my iterator with a value held in some other variable. It doesn't need to be stored in, it doesn't need to be initialized with a literal variable value there. So if I make my num equal 2, I can say int I equals my num, and same condition, I less than 3, I plus plus. So we'll print I started at 2. We're going to increase to 3. 3 is not less than 3. Our loop is now over. So our iterator can start wherever we want. And
If you start it when the condition is false, would it just not run the loop?
yeah, because just like a while loop, if my condition is false to begin with, it's just not going to run anything in the loop. Yeah, good question. All right. Also, our increase to our iterator also does not need to be always plus plus. If I want to increase by 5 each time, I can start my iterator at 5 and then loop as long as I is less than 20, and then increase by 5 each time. So what would this loop output?
5, 10, 15.
Absolutely correct. Because we're going to start at 5, we're going to print it, we're going to add 5, getting to 10. 10 is less than 20. We're going to print 10, increase to 15. 15 is less than 20. Print 15, increase to 20. 20 is not less than 20. Our loop is over. And our change can even be negative if our iterator starts at a larger number and we're checking as long as it's bigger than a smaller number, we can have our change be negative. So if I start at 20 and I loop as long as I is greater than 0 and I subtract 4 each time, what will our output look like here? Any guesses as to what our output would look like here?
20, 16, 12, 8, 4.
Absolutely correct. 20, 16, 18, 20. Wow. 20, 16, 12, 8, 4. We're subtracting by 4 each time, and we're not going to include 0 because that's not part of our condition. No matter the circumstance, we're going to be using our compound assignment operators when we update the variable, or when we update that iterator. So we can use plus equals, we can use minus equals, we can even use times and divide equals if we so choose. But so whatever update we want to do, we should use one of those compound assignment operators. And just be aware, even a minor change to the Boolean condition can change the output of your loop. So in that example from before, I had my I greater than 0. If I change it to be I greater than or equal to 0, I will include an entire additional value. I will include 0 in my output where I didn't include 0 before. So it's important to keep track of your condition and your starting variable because those can both affect your output. So if your condition is slightly wrong, if you're going to miss one value or you're going to loop one too many times, this is called an off by one error. And often these errors are caused by the condition being slightly wrong, being not greater than or equal to, or including something you didn't need to. So you can usually fix these errors by changing the condition for our for loop. We learned about while loops last time, and it's totally possible to write for loops as while loops and vice versa. As long as we're keeping account of something, we can totally write a while loop version of the same for loop. So we can see all of the same elements present in both of these. We've got our initialization of that variable, we've got that condition, and we've got that increment. But it's all more localized in my for loop, whereas it's kind of spread out in this while loop. So what are advantages of using one or the other? While loops are most useful when we do not know how many times we're going to be looping before we start looping. So this is often useful when we're working with user input and we're expecting the user to give us some type of input. We don't know how long it's going to take for the user to give us that input. So we can't say, I want to ask exactly this many times, and then if they didn't give me input, our program breaks. So while loops are very helpful when we don't know how many times. And for loops are most useful when we do know how many times we're going to be looping. And even though I could use a while loop to do that same thing, as we can see in that example, a for loop allows us to save some lines of code, and it lets us centralize where all of our controls for our loop are. And it's much more difficult to create an infinite loop when we're using a for loop, just because of the way that it's structured. We can see all of the parts and where they are. So generally, for loops are the best when we do know how many times we're looping, while loops when we don't. So a potential use case for a while loop, we're asking for a password from the user, and as long as the password has not been, or is not 8 characters long, we're going to keep asking for a password. So in this example, the user is going to keep entering until their password is at least 8 characters. We don't know how long that's going to take. They could just press the letter F and enter over and over and over again forever. So we don't know how long this is going to take, which is why a while loop is super useful. If I wanted to print all the numbers that are divisible by 3 between 0 and 100, that is a much more useful use case for a for loop. Because I know I'm going to start at 0, I'm going to go up until 100, and I'm going to include all my numbers that are divisible by 3. I'm going to say I mod 3. If that equals 0, we're going to print that value. Now, is it possible for me to rewrite this loop such that I do not need an if statement? Could I restructure it?
Could you put a while on the outside? Or are we just using for loops only?
Just using a for loop. Is it possible to rewrite this for loop so that I don't need to do this if statement?
Increment by 3, right?
Exactly. If I change my update value to only update by 3, the only values of I that are going to exist are multiples of 3. So then I can just print my value of I each time through the loop without needing to check, oh, is this number divisible by 3? Because we're only going to update by 3 every single time. So, does that all make sense? For loops? Cool? Sweet. All right, folks, that is our lesson for today.